Hello everyone. So today let's study about smog. So the word smog is derived from smoke and fog. Smoke consists of tiny particles and gases released into the air from burning materials such as coal, wood, oil, or other fossil fuels. It is typically associated with human activities like industrial processes, residential heating, vehicle emissions, and open burning of waste. Smoke contains pollutants such as particulate matter, carbon monoxide, sulfur dioxide, and various hydrocarbons. Fog is a natural atmospheric phenomenon consisting of tiny water droplets or ice crystals suspended in the air near the ground. It forms when the air temperature drops to the dew point, causing water vapor to condense. Fog is more common in cool, humid climates and it often occurs in the early morning or evening. So there are two types of smog. First is classical smog and other is photochemical smog. Classical smog. It is also known as London smog or reducing smog. It is a type of air pollution that occurs in cool, humid climates. As these cool temperatures and high humidity conditions are conducive to the formation of smog, as they facilitate the condensation of water vapor around smoke particles. It is a mixture of smoke, fog, sulfur dioxide. Classical smog is chemically reducing in nature, means it can gain electrons in reactions. This property distinguishes it from other types of smog, such as photochemical smog, which is oxidizing in nature. The sulfur dioxide in the smog can react with other compounds in the atmosphere, leading to the formation of sulfuric acid and other sulfur compounds. Photochemical smog is a type of air pollution that forms in warm, dry, and sunny climates. It is distinct from classical smog and is often referred to as oxidizing smog due to its high concentration of oxidizing agents. The main components of this smog is unsaturated hydrocarbons and nitrogen oxides. In the presence of sunlight, nitrogen oxides and volatile organic carbons undergo a series of photochemical reactions. Sunlight provides the energy necessary for these reactions, leading to the formation of a variety of secondary pollutants. One of the key components of photochemical smog is ground level ozone, which forms when nitrogen oxides react with VOCs in the presence of sunlight. Other oxidants include peroxyacetyl nitrate, hydrogen peroxide, and aldehydes, which are also formed through complex photochemical reactions. Photochemical smog is rich in oxidizing substances like ozone, which can accept electrons in the chemical reaction, thereby acting as oxidizing agents. London smog, days of toxic darkness. So on December 5th, 1952, the London sky was clear, but the weather was significantly colder than usual, as it had been for several weeks. This cold spell led to increased burning of coal for heating purposes. As a result, residents of London burnt large amounts of coal, releasing vast quantities of smoke and pollutants into the atmosphere. The smoke from household chimneys contributed significantly to air pollution. The winds were light, means that there was very little atmospheric movement in order to disperse the pollutants. So the pollutants they were concentrated at a place. Additionally, the air near the ground was moist, which turned out to be the ideal condition for the formation of radiation fog. Radiation fog forms when the ground cools overnight, causing the air near the ground to cool and reach its dew point, leading to condensation. During the day of 5th December, the fog that formed was not particularly dense but had a dry, smoky character due to the pollution. As the night fell, the fog thickened considerably, reducing visibility to just few meters. And this was due to the accumulation of pollutants and moisture, which created a dense, smoky fog. The thick smog brought road, rails, and air transport to the standstill. Visibility was so poor that it was not safe to travel, leading to widespread disruptions, and the smog even penetrated indoor spaces like theaters, causing performances to be suspended as conditions became unbearable for audiences and performers. This smog persisted from 5th to 10th December, stewing and growing denser as more pollution was added each day. The lack of wind and atmospheric movement means that the pollutants were trapped near the ground. Pollutants were not able to disperse. Finally, winds from the west blew the smog down the Thames estuary and out into the North Sea, clearing the air over London. So you can have a look at some of the images of London smog. Health effects of the London smog. On the week beginning the 5th December 1952, thousands of Londoners died in the worst air pollution disaster on record. The deaths which resulted from this smog can be attributed primarily to pneumonia, bronchitis, tuberculosis, and heart failure.